two questions. One is, in which situation the average speed and average velocity to be equal? As I already told you, speed and velocity are synonymous to the distance and displacement. When a body travels in a straight line, and if you try to calculate the average speed and average velocity, both will have same value as long as there is no change in direction. And the second one I have received is about the kinematic equations of motion, which I am going to deal with in the last part of this session. Between the last half an hour, I will be dealing with that. So with this, we will proceed to the next concept called relative velocity. We will be dealing with the relative velocity. As you all know, motion is not absolute. It is only relative. And we are going to talk about relative velocity. Many a time you might have traveled in trains. When you are sitting in a train, you might have seen on the other track a train goes. To the left of you, a train goes in the opposite direction. To the right of you, a train goes in the same direction. You have felt a different experience by seeing the motion of these two trains. If you have ever come across a train moving in the same direction as yours, then you will feel that the motion is very, very slow. Whereas, if you happen to see a train which is traveling in the opposite direction, you will feel as if the train is moving with a tremendous speed. And both these things are not true. It is your perception that it is going faster or slower. And the quantity involved in this is relative velocity. How the velocity of an object is perceived by another body. Another body may be at rest or may be in motion, either in the same direction or in the opposite direction. So it is the perception of the velocity of one object with respect to the other object. And we are going to derive a formula for the relative velocity. Let us say there are two objects A and B, and I will take the initial position of this object A as x0, and after a time at t0, and after a time t, it comes to a position xa. Similarly, the body B, initially it is at the point xa0, and xat. Here it is xb0 and xb of t. And how we are going to find out the relative velocity between these two objects? Let us try to write the expression for this displacement. Let us first write xa. Xa is equal to the xa of t is equal to. This is the expression for the displacement of the object A, and this is equal to the position of the object A initially plus the velocity with which it was traveling initially into t. Talking about this part, it is displacement is equal to velocity into time. Velocity is equal to displacement by time. Therefore, displacement is equal to velocity into time. Therefore, since it is the body A, I put a suffix A here, and this O represents the initial position 0. And similarly, if I try to write the expression for the object B, I will write it as xb of t will be equal to the position of the object B initially plus its velocity dv at a time t. Let us take it as equation 1 and 2. Now, let me find out that delta x. What is delta x? The change in displacement. So I will try to find out xa minus xb. Xa xa of t and xb of t. This will be equal to xa of O plus ba of t minus, for xb of t, I can write xb at O plus bb at t. And now, if I have to simplify this, I will write xa minus xa of 0 minus xb of 0 plus ba of t minus bb of t. Okay? And if you try to form the analogy with the formula xa is equal to x naught plus b into t, this term represents what? The difference in the initial positions. And this is the difference in the velocities of the body after time t. And therefore, this precisely, it denotes Va minus Vb. That is the velocity of the object A in respect of the velocity of the object B. So this VA B is called VA minus VB. And this is to be read as the relative velocity of the body A with respect to B, VAB, is equal to VA minus VB. Similarly, we also can write VBA will be equal to VB minus VA. That is, relative velocity of the object B with respect to A is VB minus VA. And we always should know that VAB is equal to minus VBA. So this is the expression for the relative velocity of the two objects A and B. We have done the derivation. I repeat once again. We have started with the equations for the displacement traveled by the body A and body B. Xa of t is xa of at O plus Va into t, where displacement is equal to velocity into time. Since it is the first object A, we have written Va into t. Similarly, for the object B, we have written this equation xb of O plus Vb into t. And if you try to find out the delta x, you will get xt minus xa of t by xb at t. So if you simplify this, you will get a term Va of t minus Vb of t, which is similar to Va minus Vb, which is nothing but the difference in velocities between the objects Va and Vb. This we are going to talk it by a term VAB. We call it as relative velocity of the object A with respect to B. VAB is equal to Va minus Vb. We also can find out the relative velocity of the object B with respect to A, which is VBA, which is Vb minus Va. And we must know that VAB is equal to the minus of VBA. So with that, the derivation is over. We will go in for a small PPT with some more numericals. Now look at this. You can see the two objects in the first figure moving in the same direction. Whereas in the second one, you can see the two toy cars, whatever, it travels in the opposite directions. Therefore, relative velocity is the velocity of any moving object as perceived. When I say as perceived, as thought, as felt from another moving body. Now, expressions we have done it, the same expressions we have shown. So, two objects A and B at rest at two initial positions XA at origin O, XB at origin O respectively. They move in a straight line, that is at assumption. And the velocities are VA and VB. We write the position of the object at any given time t. XA of t is equal to XA at O plus VA into t. XB of t is equal to XB at O plus VB into t. Now we have to calculate the net displacement, which is delta x, which is XAB. We have to find out the difference in the two equations, XA of t and XB of t, which is precisely, if you simplify, you will be getting XA minus XB at the origin O plus VA minus VB into t. If you draw the analogies to the earlier equation, x is equal to x at O plus B into t, in this equation, you understand that in place of V, you have got VA minus VB. So the term VA minus VB resembles V, and this VA minus VB is called the relative velocity. VAB is the relative velocity of A with respect to B. Similarly, we can say VBA as VB minus VA, which is the relative velocity of the body B with respect to A. Now we go for some position time graphs of the two bodies. In the first graph, you can see the two objects A and B are moving in the same direction with the same velocities, but they are not starting at the same point. Therefore, they are shown by two straight lines parallel to each other, and time on the x-axis, and y-axis you have got displacement. Similarly, if you see the second graph, you can see A and B, they are crisscrossing at a particular point. They overtakes. Therefore, the body A overtakes B at a point. They are moving the same directions as usual. And if you take the third graph, you can see there also the body A and B, they cross over each other, and one goes upward and one goes downward, which shows that the two bodies, though they are having uniform straight line motion, they move in the opposite direction. So the three graphs are very important. The first graph shown by a set of parallel lines and equidistant, that is about the objects having same velocity starting at two different points. And graph B denotes the positive velocities of the two objects A and B, where VA is greater than VB. And in the third graph, you can see one goes up and the one curve comes down. Therefore, we understand that the body A and B, though they are having uniform motion shown by a straight line, they move in opposite directions. So these are the position time graphs. And now let us go for example question. Train A is moving on a straight track from north to south at a constant speed of 45 meters per second. And this question is in your INTEXT question in your NIOS module. While train B is moving at a constant speed of 56 meters per second from south to north. Look at the words. A travels from north to south and body B is moving from south to north. What do we understand? We understand that the body A and B are moving in opposite directions but in constant speed. What is the velocity of train B with respect to train A? The word velocity of B with respect to A means we have to find out VBA. VBA is nothing but VB minus VA. In this case, we have taken VA to be minus 45 meters per second and VB to be plus 56 meters per second because they travel exactly in opposite direction. One is taken as negative and one is taken as positive. And we can ask the question whether we can take VA to be 45 and VB to be minus 56. Yes, it can be done. It is only a convention, a convenience that you can take one as positive and one as negative. The answer will not be different. It only shows the plus and minus only shows the direction of choice. Now, what we are asked to find out? The velocity of the body B with respect to velocity of body with respect to A. VBA, which is VB minus VA, which is equal to 56 minus 45, which is equal to 56 plus 45, which is 101 meter per second. Now you can see, I am sitting in the body, I am sitting in the train B. I'm seeing a train A. My train is going at a speed of 56 meter per second. But I am seeing another train which is moving at a speed of 45 meters per second in the opposite direction. But what I will feel is that train A is not going at 45 meters per second, but to me it is 101 meters per second. But if the person sitting at body B, he also will be seeing I will be traveling at a speed of 101 meters per second, but in the opposite direction. So this is precisely the relative velocity of two bodies A and B. Now let us go for the concept of acceleration. Acceleration is defined as the rate of change of velocity, which means how the velocity of an object changes with respect to time. And you know acceleration is a vector quantity because velocity is a vector. And as you know, distance and displacement are measured with the unit meter, speed and velocity by SI unit meter per second, and acceleration is measured by an SI unit called meter per second square. And when the acceleration is not uniform, then it is changing, just like we have found out the average speed, average velocity. Here we have to find out the average acceleration. Acceleration is nothing but delta V by delta T. By delta V, it means change in velocity. Delta T denotes the change in time. And how the velocity changes? It changes from the initial value V1 to final value V2. Similarly, time changes its value from T1 to T2. Therefore, the average acceleration A bar is equal to delta V by delta T, which is equal to V2 minus V1 divided by T2 minus T1. Look at the cursor, the previous slide, and you can see the graph. On the y-axis, you have got velocity. On the x-axis, as usual, you have got time. You know that slope of the graph will give you acceleration. Here, what is there on the y-axis? Velocity is there on the y-axis. What is there on the x-axis? Time. Therefore, the quantity along the y-axis divided by the quantity along the x-axis, that is velocity by time, will give you the acceleration. And in this case, it gives you average acceleration. Now, we will switch over to velocity time graphs. Now, we must know that area under a velocity time graph gives a displacement. And you can see in the first graph, on the x-axis we have time, on the y-axis we have got velocity in meter per second, and we have got a straight line, not at its origin, but at some point in y. Therefore, the motion is uniform and it is moving in the positive acceleration and in the positive direction. And if you see, look at the graph 2, you can see a straight line showing it is a uniform motion, uniform acceleration, but it goes downwards. It moves that the body is moving in positive direction but negative acceleration. But in the third case, you can see the motion, though it is uniform, it is going down to the negative of the y-axis. So it is changing its direction. So these are the three velocity time graphs. And understand, the area under a velocity time graph gives displacement of the object. This particular concept is very important when you are going to derive the second equation of motion. This is important. Please understand, I repeat once again, the area under a velocity time graph will give you displacement. And let us go in for an example question. The position time graphs of two bodies A and B are shown in the graph below. Which of these bodies has a greater velocity? For the time being, look at with the PPT. Once we move out of PPT, I will also do it on the board. I will do much about what is slope. In this case, you can see there are two graphs A and B. And you can see body A is having a greater slope than body B. And because it is having a greater slope, what is the slope? Slope is nothing but the quantity along the y-axis divided by the quantity on the x-axis. What is there on the y-axis? The position, that is distance, by time. And therefore, this precisely gives the velocity, or y-axis you can take displacement also. So this precisely gives the velocity of the object A and B. So when the slope is more, the velocity is more. When the slope is less, the velocity is less. If you look into the curve shown by A and B, A is having more slope than B. More slope denotes more velocity, and therefore body is moving with a greater velocity when compared to body B. And let us go into another question. The velocity of a bus traveling in a straight line changes from 0 to 36 meters per second in 6 seconds. Calculate the average acceleration of the bus. Now look at this. What are the quantities given? It is given that time. The initial time t1, let us take it as 0, and the final time t2, let us take it as 6 seconds. Therefore, t2 minus t1 is 6 minus 0, which is 6 seconds. And let us see how the velocity of the bus changes. It changes from 0 to 36 meters per second. Therefore, initial velocity v1 is 0 meter per second, and the final velocity v2 is 36 meters per second. Therefore, the formula for acceleration is v2 minus v1 divided by t2 minus t1, which is nothing but 36 minus 0 divided by 6 minus 0, which is 36 by 6, which is 6 meter per second square. Meter per second square. So this is the average acceleration of the object. We'll come out of the, for a moment I'll come out of the PPT, we'll go back, I'll start explaining with the board. As I have told you, if you have the displacement along the y-axis and time along the x-axis, the graph will tell us whether the body is in uniform motion or a non-uniform motion. The first one, A, represents the body in uniform motion, and B represents non-uniform motion. And in both the graphs, the slope of the graph will give us the velocity of the object. When I say the slope, what I mean is delta y by delta x. That is nothing but the quantity along the y-axis divided by the quantity along the x-axis. I choose the two time intervals, t1, t2. Correspondingly, I take x1, I take x2, and therefore the slope is nothing but y-axis, that is x2 minus x1 by t2 minus t1, that is delta x by delta t. So this is going to give us the velocity of the object. And as I told you that this slope, how to find out? Another concept is, suppose if I choose a point here, the precise definition of a slope is to draw a tangent at the point. Suppose I want the velocity of an object here. At this point, I should draw a tangent. And this theta, the tan theta, will give us the slope. And as you know, the value of tan theta, let us say tan theta 30, 45, 60, 90. At tan 30, it is 1 by root 3, 1, root 3, and of course infinity. And you can see this is 1 by root 3, 1 by 1.732. It is a number less than 1. Next, tan 45, 1. And tan 60 is root 3, it is 1.732. So what we understand, as theta increases, tan theta increases. As tan theta increases, the slope increases. And therefore, in the previous question, what we have seen, A and B, we told that body A travels faster. It is because if you take it as theta A, if this is take it as theta B, theta A is greater than theta B, therefore tan theta A is greater than tan theta B, slope of A is greater than slope of B, and therefore velocity of A is greater than velocity of B. Therefore body A moves faster. So this is the concept of slope. Now we are going to move. Yes.
One more question is there.
Yes, sir.
From Visakhapatnam.
Yes.
When this average acceleration becomes 0, average acceleration becomes 0.
When will the acceleration become 0?
Yeah.
Acceleration is 0 means there is no velocity at all, no change in velocity. Acceleration will be 0 because acceleration is nothing but the change in velocity by time. If acceleration has to be 0, which means change in velocity is 0, which means the body continues to move with the same velocity.
Okay.
Yeah. Now we will move to the concept of instantaneous velocity. This is a very tricky concept. Instantaneous velocity. Now, for example, if I again take a time along the x-axis and a displacement along the y-axis, and if I get a graph like this, now I want to calculate the velocity. Now, generally what I do, I choose 2 points and I try to find out this is t1 and this is t2 and this is x1 and this is x2. Then what I try to find out is the velocity is equal to delta x by delta t, which is nothing but x2 minus x1 divided by t2 minus t1. But I don't want to find out the velocity of the object between any 2 time intervals. I am interested in finding out the velocity of the object at a particular instant of time, which means I don't want this big time interval, I want a particular point. Mathematically, how will you do it? Suppose if you try to squeeze it, now T2 coming towards T1 or T1 coming towards T2, what will happen? When T1, T2 slowly merges here, X2 and X1 will be also start to merge. Then when T1 and T2 they exactly coincide on each other, the X1 and X2 will also be coincide on each other. Therefore, what we'll be getting, we'll be getting a particular point. So this particular point will give us the value of instantaneous velocity. And mathematically it is possible, but physically it is very difficult. Therefore, what we say, instantaneous velocity means it is the velocity of the object at the particular instant of time. And this we write it as V bar is equal to limit delta t tending to 0, delta x by delta t is equal to dx by dt. What is this? Look at this, delta t tending to 0. I told you that t1 and t2 they move closer. As they move closer, the distance between the 2 points goes on decreasing. And when it is going to merge, then what will happen? Suppose if t becomes 0 and this will blow up, t becomes infinity. Therefore, it should not be exactly 0 and it should not be a larger value. It should be as low as possible, tending to 0, tending to 0. In that case, it is going to be a single point, and this point will give us the velocity of the instantaneous velocity. Once again, I'll tell you, this instantaneous velocity, instantaneous speed, instantaneous acceleration, all these concepts they are going to give us a formula to calculate the velocity, the speed and the acceleration at a particular instant of time. We don't want a time interval, larger time interval. We squeeze the time interval slower, less and less, and we find out the value of any object, velocity, speed or acceleration at that particular instant of time. And this speed, this velocity, this acceleration is called instantaneous velocity, instantaneous speed and instantaneous acceleration of the object. Now I'll go back to the slides. Yeah, it is defined as the velocity of any moving body at any instant of time cursor. In other words, it is defined as the velocity when the time interval becomes infinitesimally small. This word is very important. This is what I told you, delta t tending to 0, not 0. It is infinitesimally small. It is as if it is 0, it is not 0. It is the rate of change in displacement with respect to change in time at that instant. Therefore, the instantaneous velocity v is equal to limit delta t tending to 0, delta x by delta t is equal to dx by dt. As I repeat again, previous slide, as I already told you, this should be read as instantaneous velocity v is equal to limit delta tending to 0, delta x by delta t is equal to dx by dt. I told you that the tangent drawn at a point will always give the instantaneous velocity in a displacement time graph. Similarly, instantaneous speed, same concept. Here limit delta t tending to 0, delta x by delta t, modulus we have given, modulus of dx by dt. Why modulus? Because we know that speed and velocity, they are one and the same, but speed is a scalar, velocity is a vector. Velocity can be either positive or negative, but speed can always be positive. It can never be negative. Even if you get a negative value, we will be considered as positive only. Therefore, we put a modulus. So modulus of 24 is 24 meters per second. Modulus of minus 24 meters per second is also equal to 24 meters per second. And finally, we have instantaneous acceleration. Again, same formula, same concept. A is equal to limit delta t tending to 0, dv, delta v by delta t is equal to dv by dt. Yes. Now, we move on to the third part of the discussion. And yes, I'll just share the PPT now. The kinematic equations. Kinematic equation, they will give us to solve the three equations of motion, which will help us solve a lot of numericals. We have got a certain assumptions in this, that these equations are valid only when the acceleration is constant. And as I already told you, the notations, the initial time is 0, final time is t. Initial displacement is x naught, final displacement is x. Initial velocity is v naught, final velocity is v. And accordingly, we have got three equations of motion. V is equal to v naught plus at, x minus x naught is equal to v naught t plus half at square, and the third equation 2a into x minus x naught is equal to v square minus v naught square. So these are the three equations which we are going to derive. Now let us going to derive the first equations of motion. By definition, we know that acceleration is equal to the rate of change of velocity, like a is equal to v2 minus v1 divided by t2 minus t1. And therefore, we will replace with the known quantities v2 as v, v1 as v naught, and t2 as t, and we know initial time t1 is 0. Therefore, the equation becomes a is equal to v minus v naught divided by t. Therefore, if you rearrange all these terms, v minus v naught is equal to a times t. Therefore, v is equal to the minus v naught. When it goes to the right hand side, it becomes plus v naught. Therefore, v is equal to v naught plus at. This is the first kinematic equation of motion. Now, using this equation of motion, let us try to solve a numerical. A car starts at rest and travels for 8 seconds at a constant acceleration of 6 meters per second square. What will be its velocity after traveling for 5 seconds? What is given in this sum? You can see that initial velocity is 0 because the car starts at rest, and the time taken is 5 seconds. Acceleration a is equal to 6 meters per second square. V, we have to find out. So connecting v, v naught, a and t, the formula is v is equal to v naught plus a times t. Therefore, v is equal to, you substitute the values of v naught, a and t, 0 plus 6 times 5. Therefore, 0 plus 30, which is equal to 30 meters per second. Now let us go for the kinematic equation number 2. I already told you in the previous section that in the displacement time graph, the area under the curve gives the displacement. Therefore, here we take the velocity time graph and the area under the graph will give the displacement, because area under the VT curve, velocity time graph, gives displacement. We will write here, you can see the cursor will be moving now. You can see the motion of a body. It is in a straight line. It is not passing to the origin. It is starting at a point V0 on y-axis. And we have to find out the second equation of motion. And to find out, what I do is, from the end point B, I drop a perpendicular to both x-axis and y-axis. To the x-axis, I take this point as capital A, and to the y-axis, it is the terminal point of velocity V, and the intermediate points near V0 is C near the y-axis. At the far end, we have got D. Now, to find out the area under this graph, you have a trapezium. You can see the trapezium is O, A, B, C. This is the trapezium. And you have to find out the area under this trapezium. This will give you displacement. How displacement has changed? It has changed from x0 to x. Therefore, change is x minus x0, which is equal to the area under the trapezium OABC. Therefore, x minus x0 is equal to, as you all know, the formula for area of trapezium is half times the sum of the altitudes into the base. That is half into OC plus AB into OA, the base. Therefore, x minus x0 is equal to half times. Look at this, what is OC? OC is the starting point is O, end point is V0, therefore it is V0, plus AB. What is AB? AB is the starting point is 0 and end point is V, therefore V minus 0 is V, into OA is nothing but the time taken. Starting point, the time is 0, and at A the time is T, therefore it is T. Therefore I get the equation x minus x0 is equal to half times V0 plus V into T. Let me take this equation as equation number 2, which we will be using it later. We have learned from the first equation of motion just now, V is equal to V0 plus AT. Now, let us use this equation into equation 2, because equation 2 has got a component V there inside the bracket. Now look at that equation 2. My equation 2 will become now, left hand side, x minus x0 is equal to half times, look at this, I have got V0 plus, for that V I will have again V0 plus AT. So I have got V0 plus V0, which will give us 2 times V0 plus AT multiplied by T. Therefore, x minus x0 is equal to, I will split it up outside, 2 V0 by 2 plus half A T square. So 2 and 2 will get cancelled. The first term will be V0 into T, and the second term will be half A T square. This is the second equation of motion, the kinematic equation number 2. X minus x0 is equal to V0 T plus half AT square. I repeat again, in the equation 2 you have x minus x0 is equal to half times V0 plus V into T. This V in the bracket should be substituted from equation 1 as V0 plus AT. Therefore, equation 2 becomes x minus x0 is equal to half times, look at the bracket, already one V0 is there. When we substitute for V, another one V0 will come. Therefore, V0 plus V0 will give you 2 times V0 plus AT into T. Now, I split this up into 2 terms. the first term is 2 V naught by 2 into T. So 2 and 2 will get cancelled, therefore I will get V naught into T. The second term will be half AT into T, that is half AT square, and calculate the distance it travels in this time duration. Now, as you know, the train starts from rest. Therefore, V naught, initial velocity is 0 meter per second, and time taken T is equal to 12 seconds, and the acceleration is 10 meter per second square. Therefore, from the second equation of motion, we have x minus x naught is equal to V naught to T plus half AT square. Here, V naught is 0, therefore the term goes off. The second term remains half AT square. When you substitute for A as 10, 12 for T, you will get half into 10 into 12 square. 12 square is 144, into 10 is 1440, divided by 2, you will get 720 meters. Therefore, this is the distance traveled by the train in 12 seconds of time. Now let us go to the final kinematic equation, number 3. Previously, I told you that we have to remember this intermediate equation, x minus x naught half times V plus V naught into T. This is the equation which we derived in the second equation of motion. Also, in the first equation of motion, if you rearrange the terms between V is equal to V naught plus A into T, if you try to bring time along the left hand side, you will get T is equal to the final velocity V minus initial velocity V naught divided by acceleration. And substituting this, x minus x naught is equal to half V plus V naught into, instead of T, we will write V minus V naught divided by A. I repeat again, the intermediate equation x minus x naught is equal to half times V plus V naught into T. And we need to substitute for T here. How will I substitute? From equation number 1, I will rearrange the terms such that time T is the change in velocity by acceleration, that is V minus V naught by A. Substituting for T in this equation, I will get x minus x naught is equal to half plus within bracket V plus V naught into V minus V naught by A. You can say two terms, V plus V naught into V minus V naught. This is of the form A plus B into A minus B, which is precisely A square minus B square. Therefore, you will get V square minus V naught square. And the 2 on the denominator will go to the numerator on the left hand side. Therefore, 2A, the A also will go to the left. 2A into x minus x naught is equal to V square minus V naught square. And this is the equation, the kinematic equation number 3. 2A into x minus x naught is equal to V square minus V naught square. So we have seen 3 equations of motion. Now, using the third equation of motion, let us try to solve a numerical. The numerical is like this. Find the distance covered by a body moving at an acceleration of 8 meter per second square when its velocity reaches 16 meter per second. Now, what is given here? This body started at rest. Therefore, V naught is equal to 0 meter per second. And the final velocity is 16 meter per second. Therefore, V is equal to 16 meter per second. The acceleration A is equal to 8 meter per second square. Now, let us substitute all these 3 values in the third kinematic equation of motion, namely 2A into x minus x naught is equal to V square minus V naught square. Therefore, we need to find out x minus x naught. What is that? The distance covered is equal to V 16, and for V naught we have got 0. Therefore, it is 16 square on the numerator. In the denominator, 2a, 2 into a. A is 8. Therefore, 16 square is 256 divided by 16, which is equal to 16 meter. Now, I'll just come out of the PPT. I'll try to explain about the gravity. We will try to find out, learn what is the motion of an object under gravity. Suppose this is a big tower, or you can say it's a skyscraper, a very tall building. On the top of it I am standing. Suppose I am dropping an object. When I am dropping an object, what will happen to the object? And when the object comes down, ultimately it falls and touches the ground. Why? Because it is going to be acted upon by the gravity of the earth. While the object comes down, what happens to it? Whether it moves with the same velocity or whether it moves with a different velocity. That we are going to see. We know that, we have heard, the acceleration due to gravity of a earth is denoted by the symbol g, which is equal to 9.8 meter per second square. 9.8 meter per second square. What does it mean? It means, now I am going to drop an object from the top of the skyscraper. When any body is dropped, its initial velocity is 0. It is not projected. It is not projected. It is dropped. So it is dropped with no velocity. Therefore, here V0 is equal to 0. Now, as it goes down, what happens to it? Look at this. V is equal to V0 plus A into T. And therefore, V is equal to, this V0 is anyhow 0. This A is nothing but G into T. Now, suppose if I try to find out when T is equal to 1 second, what happens you see? Velocity is equal to 9.8 into 1, which is 9.82 meter per second. Now, when T is equal to 2, what is the velocity? V is equal to 9.8 into 2, which is 19.6 meter per second. When T is equal to 3, it is V is equal to 9.8 into 3. So it goes like this. It means that as the body going downwards towards the earth, its velocity goes on increasing with the time. So the body is accelerated due to gravity. This is the motion of the gravity, and you must understand that the velocity changes at the rate of 9.8 meter per second. Look at this. It is 9.8 meter per second. Then it moves to 19.6 meter per second. What is the difference? The difference is 9.8 meter per second. Therefore, when you say 9.8 meter per second square, it means that any object which is falling freely under gravity, which means there is no external force on the object. It is falling freely under the gravity of the earth. Its velocity will go on increasing at the rate of 9.8 meter per second. So this is the meaning of the acceleration due to gravity. Now let us go for some of the in-text numericals. I'll share it with you. I have summed it up. A free fall of the body towards the earth is a common example of constant acceleration, denoted with the symbol g, and the value is 9.8 meter per second. When we say 9.8 meter per second square, it means that the velocity of any freely falling object increases at the rate of 9.8 meter per second in each second of time. Now let us try to solve some in-text questions given in the NAOS module. The first question: is it possible for a moving body to have non-zero average speed but zero average velocity during any given interval of time? If so, explain. We have already told that speed is a scalar quantity. It does not depend upon direction, but velocity is a vector. It depends upon direction. When an object travels forward and again travels backward, there is a possibility for the average velocity to become zero, but the average speed can never be zero. It is always a non-zero quantity. You can see the solution. Next, can a moving body have zero relative velocity with respect to another body? If so, give an example. Yes. Can you understand? Relative velocity, what we told? By relative velocity, we told it is the velocity of an object as perceived, as felt by another object, either at rest or in motion. So in that case, can you say the moving body to have a zero relative velocity? Yes. Suppose I travel in a car at a speed of 60 kilometers per hour. Then along with me, there is another car going the same direction with the same velocity 60 kilometers per hour. In this case, both of us will be traveling together. The distance traveled will be same, the direction is same, and therefore there won't be any change in the velocity. The person in the car A will feel that the person in B is not having any motion at all. The person in B will also feel that velocity of the body A is zero. So there is a possibility that the relative velocity of any body, moving body, to be zero, provided if the two objects move in the same direction with the same velocity. Now let us try to solve another in-text question of the NIOS module. A lady drove to the market at a speed of 8 kilometers per hour. Finding the market closed, she came back home at a speed of 10 kilometers per hour. If the market is 2 kilometers away, calculate her average speed and average velocity. Why the word average is given here? It is because the lady is moving with a different speed, 8 and 10. Now, to solve this, we need two formulas. What is that? Average speed and average velocity. What is average speed? It is the total distance traveled divided by the total time taken. What is the formula for average velocity? It is a total displacement traveled divided by the total time taken. When I say total time taken, the time taken for going to market and the time taken for coming back. So time going, time G, and time coming, time C. So G represents, the suffix represents going, and the suffix C represents the time to come. Let the time taken by the lady to go to the market be T suffix G, and that taken by the lady to return be TC. Now, we know the formula for time in terms of distance and speed. We know that distance is equal to speed into time. Distance by speed. Here, distance the lady travels is 2 kilometers and the speed with which she travels is 8. Since both the units are in kilometers, we keep it as kilometers only. Therefore, the time for going is 2 by 8 hours. That is 0.25 hours. Similarly, the time taken for coming back, TC, is equal to the distance traveled. Again, the market and home, same distance only, therefore 2 kilometers on the numerator. Whereas speed is different this time. Now, while coming back, the lady travels at a speed of 10 kilometers per hour. Therefore, TC is equal to distance by speed of coming back, which is 2 by 10, which is 0.2 hour. Therefore, the total time taken is TC plus TG is 0.25 plus 0.2. Now let us calculate the average speed. Average speed is equal to total distance traveled divided by the total time taken. What is the total distance? From home to market 2 kilometers, market to home is 2 kilometers. Therefore, the total distance traveled is 2 plus 2, which is 4 kilometers. And the denominator we have the total time taken for going and coming, which we have calculated as 0.25 and 0.2. If you simplify this, 4 divided by 0.45, which will be 8.89 kilometers per hour. But when you try to calculate the average velocity is equal to the total displacement by the total time taken. Here, the total displacement means displacement is nothing but the distance traveled in a specific direction. The distance traveled in the forward direction is taken as positive and in the reverse direction is taken as negative. While going from home to market, the lady has traveled plus 2 kilometers. While returning to home from the market, she has traveled minus 2 kilometers. Therefore, the total displacement is 2 minus 2, which is equal to 0 kilometer, and therefore the average velocity is 0 kilometers per hour. Now, the last question. Draw the position time graph of a body moving under zero acceleration. Now, the graph shows that x-axis you have got time, y-axis you have got extent. And the position time graph, it shows that it is a uniform motion, and a straight line shows that it is having a constant zero acceleration. So with that, we have come to the end of today's session, motion in a straight line. I hope I was able to put across the concepts relating to that. So thank you NAYs for having us a chance, and children, use the time judiciously using Swayamprabha of NAYs, and in the COVID time, take care of your health, stay home, stay safe. Thank you so much.
Thank you, learners, for this class, and thank you, sir,